And I expect that you download those files from the chat window and try to run on your own system as well. Let me see if the file is transferable or not from the chat window. Data imputation, and I want module 1. Okay, let me run first experiment, and then what I'll do is as soon as my experiment ran on my system, I'll post the notebook files along with the data file onto the WhatsApp group. From there, you can download those Jupyter notebook files and the document and your data set, so that you can also run the same program on your end too. And what I'll do is I'll run the complete program on the Google Cloud environment, which is called Colab. Okay. So Colab Google. This is very similar environment which was also provided by the Jupyter Notebook. Okay, I often use Colab, so I do have some already recent files. Some more codes are already there in the Google Drive. What I'll do is I'll upload it from the external drive, which is I think module 0. Let me run module 0. This was the first experiment, and in fact, the methodology is your removal of those instances where you have missing values. So it is also called complete case analysis, CCA, where what we do is we try to find those instances where any of the cell is carrying not a number or a missing value. If you get such kind of instances, we will be simply removing those instances. And this was the first approach that we have seen in the morning, at how we deal with the missing problem or the missing data problem with the help of removal of the instances. Okay, so this was a Jupyter notebook which was prepared for complete case analysis. Let me clear the all outputs, and it is also expecting a train.csv file which is locally kept at my drive, which is this one. And I hope you remember in the morning session we take this train.csv file, which was a data set belonging to the Titanic passengers, and its objective is to whether the person is survived or not survived. Okay, we have total 12 instances, and I hope you remember this particular file was also carrying the noise instances too. Means the missing value, like you can see this one, the 19th row, the age column or the cell value intersecting 19th row and F column is right now black. So it is showing that there is no value. There is missing value, in fact. And similarly, in the cabin also, you can see that there are lots of missing values. So this is a particular problem where a data set is given to you and you have missing values. Now, we are interested in applying those missing imputation, or in fact missing handling techniques, which we have learned in the morning. Okay, let me also upload this data set. Data imputation train.csv. It's right now uploading. You can see this message is coming here. Okay, this space size is right now 85.16 GB. Let me check. To run these commands, what you have to do is there is a play button over here. You have to simply run it. Then that cell will run. And if it executes successfully, it will be notified by a green right tick. Okay. So the first thing is we will be importing the pandas so that we can import our CSV file into a data frame and then perform various data frame operations. Okay. Let me import the file. It says that train.csv file is not there, no such file or directory. We do it again. Yeah, now it is uploaded here, train.csv, and let me read it. Yeah, it ran, okay, successfully. Now, obviously, these were, okay, I think Evala we have already done. Let me not waste my time on this module. In fact, let me directly jump onto the, like this was the case study that we have seen for initial data analysis, okay, like the first few steps that we perform as soon as we get the data set. Not at all interested in this module, in fact. Yeah, okay, that it clear all outputs. Uh, Now in this particular example, we have new set of data set, which is data science job.csv. I would like to also open data science underscore job CSV file, which is your whether the person gave an interview for the role of data scientist was selected or not. This is the label which is giving you that if the person is selected, it means one, and if the person got rejected for the data science job, is zero. And in fact, in the company, you can see there are many fields which are missing. Okay, and similarly for company size also there are many fields which is missing. Your major discipline, maybe you can see that there are lots of missing values. In fact, gender, maybe you can see there are lots of missing value. So anyhow, we need those data which carries actually missing values. Okay. So what I'll do is I'll switch back to my Colab environment. Let me import the libraries. NumPy is for obviously I would be requiring to play with the arrays. That's why NumPy. Pandas is obviously for data frame, and there would be some data visualization with the help of Matplotlib. Also upload the CSV file in the environment. Yeah, uploaded. Now it is loaded. Check if top five rows and rows are depicting the attribute values, that is enrollee ID, city, development, gender, relevant experience, enroll university, education level, major discipline, and like we are interested in this label column, which is your target, which is your binary value, one who got placed and the other who got rejected. Okay. Now we are also checking for the number of missing values in each column, and we have seen in the morning also this particular formula. There we did sum. यहाँ पे भी I'm interested in the average, and in fact this is the percentage basically. If you see, it's a percentage. Like enrollee ID में there is not a single value which is missing. But if you see city development index, you will find that there are 2.5% of the data which is missing. Gender में you can see 23.5% of the data is missing. Enroll university में 2%, education level में 2%, major discipline में 14.6 है. Company size में you can like it's approximately 31%, 32%, and so. So if I correlate the theory of MCAR, where I used to say that I'll apply MCAR techniques on those cases where my missing values would be lesser than 5%. And for that, I can see that I have city development index is the column which is less than 5%. If I see gender, it is obviously 23% of the complete data. So MCAR techniques would not be feasible enough to apply. Like obviously, um, the first technique that we are seeing is removal of such columns, removal of such rows, in fact, okay, where the columns are carrying empty values or your missing values. So if I remove 23% of the data, so I would be left only with 75% or 77% of the data. So it's very useless to like use complete case analysis or removal of dropping off instances for missing values in the cases where you have noise values or missing values greater than 5%. Okay, so there are few columns where I'm not interested to apply the complete case analysis solution. Okay, so that's why I computed the percentage over here. Let me also check what is my size of the data. That is, it carries 19,000 rows approximately in 13 columns. Okay. Now this command is particularly for getting those column names where the percentage of missing values is between 0 to 5%. Okay. And if I run it, you will see that these many columns are selected like based on this criteria. Okay. And I will be applying only on onto these columns only for removal of noisy instances or your missing value instances. Okay. Let me also see what are those columns. Okay, their values. And then similarly, education level. Let me count how many, like this is a categorical column which carries 11,000 instances of graduate, masters carrying 4,361, high school 2007 17 414, primary 308. Okay, it's basically you're counting each attribute or each value of that attribute belonging to that attribute and their frequencies. Then uh, this is particularly you want to see that how much data will I be left with after dropping those instances. Initially, you had 100% of data. After dropping the columns or after dropping those instances which is carrying missing values, you would be left with only 89%, which is decent enough. Okay, so just like this statement is only to check whether how much data will be left when I drop the original instances which is carrying missing values. Now here I'm actually dropping those values. See, this is there is a function called drop NA which will drop that instance, okay, and save it into new data frame. Let me do that, and also checking what is the size of the new data frame, which is dropped one, like which is carrying only those instances, it does not have missing values, and this one is the old, like the original one. You can see that there is a difference of approximately 2000 instances has been deleted. Okay, almost 10% of the data has been removed from the missing values. Now, this is to see its effect on your distribution curve. This is an histogram plot for city development index. This one is for experience, and this is for training hours. Okay. Here, what you have done is you are actually used new data frame. Okay, and want to see its distribution difference, whether distribution difference actually, like does it disturbs the distribution curve after the removal of noise, okay, or after the removal of your missing values. I have also compared them. I'll show you here. See, this is the your original data set DF, and this one is your transform data which you generate, like which you have produced after removing the this one, after removing the missing values. Okay, let me run this and show you. Yeah, see, in this histogram plot, which is for training hours column, you can see that there are green towers and there are also red tower too. If you can see there the tiny red towers in some places, it means that the green tower has completely covered the red towers, and in few cases red towers are like they are bigger enough or bigger than the green towers, which means that, see, the red was the color given to the original data frame, okay, original data frame, which was your values without values with missing, and the green color was given to the values to the data which is removed from the which has removed the noise or your missing values. You can see that the distribution has not been much disturbed because of this complete case analysis. Okay, you can also check for okay, yeah, you can also check for the your kernel density estimation curve, okay, where green and red are exactly overlapping for both the like for both the data sets in training hours column. Okay, so their density curve is also not disturbed because of the removal. The same thing is now being performed onto the other column, which is city development index, and let us see its effect on city development index. And you can see more or less they are also very similar to the original data frame distribution or original data distribution. Even after the removal of noise also, it is maintaining the same distribution which was maintained by the original data. This is for your density plot. See, thoda sa yahan pe you can see there is slight variation with respect to the original data if you compare with the new data. Similarly, you have the experience wala. Experience where you can see there are some red towers. This is for density of the experience. Okay, so there is not much effect because of removal of the noises from the instances, and this was only the cases when you have values which is following MCAR phenomena, that is missing completely at random.